Joint variation means that one variable is directly proportional or varies directly to the product of two other variables. So the words that you'll see for translating that is y varies jointly as this and this variable, or is jointly proportional to this and this variable. And so you translate that into y equals k times x times z, or whatever the variable names are. And again, k is that constant of variation. That's always going to be the same for any varying relationships. So, example 6 here says the area of a triangle varies jointly as its base and height. Express the area in terms of base and height. So, keywords here, varies jointly. It gives us variables for the base and the height, so b and h. It doesn't give us a variable for the area, so I'm just going to call that capital A. So let me translate that. The area varies jointly, so I'm going to have direct variation with more than one variable as the base b and the height h. Then they just want us to express the area in terms of base and height. So really that's it. We don't have to find k, but do you know what it is? It should be 1/2 because the area of triangle is 1/2 the base times the height. So some variation in the real world uses more than one type, and this is called combined variation. So you'll have either direct and inverse or joint and inverse. That's combined variation. So an example here, the maximum weight that a rectangular beam can support varies jointly as its width and the square of its height, and inversely as its length. If a beam 1/3 foot wide, 1 foot high, and 10 feet long can support 3 tons, find how much weight a similar beam can support if it's 1 foot wide, 1/3 foot high, and 9 feet long. Okay, we're talking about a beam that has length, width, and height. Just to try and imagine what I'm working with here. Okay. And this beam can support weight. So say something's on it and there's a weight here. I don't know. That's what I imagine anyway. So it can support weight. So I need to come up with some variables here. Let me first identify the keywords varies jointly and inversely. Okay, so I'm going to have both types of variation here. I'm going to have multiplication and I'm going to have division for direct and inverse. So let's get some variables here. Maximum weight. I think I'm going to use m for max. As the width, I'll use w. And the square of the height, I'll use h. And length, I'll use a capital L because it's hard to see a lowercase l. All right, so the maximum weight the beam can support varies jointly. Oh, so it's not direct, it's joint. Let's change that. So that means we're going to have two multiplications here. The width and the square of the height. So not just h, but h squared, because it's the square of the height. And inversely as the length. Okay, so that's what we've got so far. Now we need to solve for k. And we're going to do that by inputting the values that were given next. So 1/3 foot wide, that's w. 1 foot high, that's h squared. 10 feet long, that's L. It can support 3 tons max weight. Okay, let's solve for k then. There's a lot of stuff going on here. 1 squared is just 1, times 1/3 is just 1/3. And I can multiply 10 to get rid of that. So let's multiply 10 to both sides so that 30 equals 1/3 k. Because that's gone. And then I just need to multiply by the reciprocal. So multiply 3 to both sides, and I end up with 90 equals k. So I've got k. Let me put it into my equation. M equals 90WH squared over L. Okay. Then I need to answer a question. Find how much weight. So I'm going to solve for M. Given 1 foot wide, 1/3 foot high, and 9 feet long. Okay. So then I just need to simplify that to see how much weight we're talking about here. So, I don't know. I'm thinking, multiplying by 1 does nothing, so that's fine. 1/3 squared is 1/9. And 1/9 times 90 is 10. So I get 10/9 or 1 1/9. What's my unit here? Weight is in tons. So I can support 1 1/9 tons, this particular rectangular beam.